Good evening, sir.
Anish, have we gone through the last class notes once? So because of we are discussing about the inductive effect.
Sir,
Okay. So inductive effect is classified into how many types, Tanishq? Inductive effect is classified in two types. What are the two types of the inductive effect, Tanishq?
permanent effect and
No, sir. So inductive effect is classified into two types. So one is called as a positive inductive effect. Another one is called as a negative inductive effect. So positive inductive effect is causes due to the presence of the electron donating groups. What are the examples of the electron donating groups means here? O minus, COO minus, tertiary alkyl group, secondary alkyl group, primary alkyl group, methyl group, okay, tritium, deuterium, hydrogens, protium. H is called as a protium. And negative inductive effect. So what is meant by the negative inductive effect means here? Negative inductive effect is causes due to the presence of electron withdrawing groups. What are the examples of the electron withdrawing group means NF3 plus, NH3 plus, SO3H plus, NO2, CN, CHO, CO, COOH, COL, CONH2, F, Cl, Br minus, I minus, OH minus, OR minus, C6H5 and H. Okay, so these are the examples of the electron withdrawing groups. Okay, here based on the plus side groups and minus side groups. So we are going to explain the stability of the carbocations. Okay, so that is only we call as a applications of the applications of inductive effect. So what are the applications of the inductive effect means? Inductive effect is used to explain Inductive effect is used to explain stability of the carbocation, stability of carbene ion, stability of the free radicals, acidity of the aliphatic alcohols and carboxylic acids, and basicity of the amines. So all these factors we are going to be explained based on the inductive effect. So actually it is very important concept for the JEE level examination. Okay. And so Sunday you have a test mark. For that Sunday I am giving the questions based on attacking reagents and reaction intermediates. Okay. I am giving the questions from here based on attacking reagents and reaction intermediates. You have a questions. Okay. And now let's see here. So we are studying about here stability of the carbocations. Stability of the carbocations is directly proportional to plus psi group and inversely proportional to minus psi groups. Okay, so yesterday we had seen two examples. Okay, in that one, so tertiary carbocation, secondary carbocation, and primary carbocation. So which one is more stable? So we give as here, tertiary carbocation is more stable than secondary. Secondary is more stable than primary. Sir, how you telling that tertiary carbocation is more stable means number of electron donating groups. Number of electron donating groups are increases. The stability also is going to be increases. Similarly, here I had given one more question. So what is another example I had given means here, if you see my here. So here also carbocation it is there and here also carbocation it is there. So if you compare these two, which one is the more stable? Which one is more stable? Two examples I wrote. Two carbocations I wrote. To carbocation. First of all, if you know the strength of the minus side or plus side groups means based on that one we can explain, sir. So in these two, which one is the more stable means first one is the more stable, sir. Which one is the more stable, sir? First one is the more stable. Sir, how you are telling me first one is the more stable means a state group is a strong electron donating group. Okay, if you see the order means your first will get as a COO minus. Okay, if you compare with the alkyl group and COO minus is it act as a strong electron donating group. Okay, so strength of the electron donating groups are increases. Their stability also is going to be increases. Now you got the clarity, sir, all of you. And I'll give one more example here. So I'll give one more example. So what is another example? Means for example, CH3 bond CH2 plus. So this is also primary carbocation, and I'm writing as here CH2 bond CH2 plus bond NO2. Okay, if we comparing these two, so which one is the more stable carbocation? Any one of you? Samhita, Sirisha. Hi Sirisha.
Hi, sir.
So today's absent. Okay. So right now, let's see. So Aditi, which one is the more stable one? Kanishk, Aditi, Sai, Akshit. Hi Samhita. I had given two structures. In the two structures, which one is the more stable carbocation? The first one or second one?
Sir, is it the second one?
My second one you can observe clearly, Samhita. So what's the difference between the first one and second one? Sir, in the first case also we have a primary carbocation. Second one is also it is a primary carbocation. But if you observe means in this one carbocation is attaches with the methyl group. Here also it is attaches with the CH2. But along with the CH2, it is attaches with the NO2 group. First of all, my question is NO2 is plus I group or minus I group? NO2. Here only it is that if you want to show means 1 second I'll show here. No problem. Here only we have a list. Okay. So once once you read the plus I groups and minus I groups, because of so many applications are there. Just to check it out. Is NO2 is the plus I group or minus I group? So where it is there NO2. So here it is there NO2.
Minus I group.
Minus I group. What is the statement I wrote here? Stability of the carbocations is directly proportional to the plus I group and inversely proportional to the minus I group. So that means minus I groups are they decreases the stability or increases the stability.
Decreases.
Very good, ma'am. Okay, so because of inversely proportional means here, sir, it decreases the stability. If the number of minus I groups are increases, the stability also is going to be decreases. So now you got the clarity, all of you. Okay, now I'm taking a little bit right now let us see. So according to that one, once you check it out, which one is the more stable one means here, first one is the more stable one. Sir, why the first one is the more stable one means here there is no electron with the drawing group. Directly electron donating group is attached to the carbocation. But in this one, electron withdrawing group also it is there. Electron withdrawing groups are they decreases the stability of the carbocations. Now you got the clarity, all of you. So these are the application oriented questions. In JEE also they are asking the application oriented questions only. Okay. Now I'm going to give one more example, here. One more example. Okay. So what is another example means? For example, CH2 bond CH2 plus, and here fluorine is there, and CH2 bond CH2 plus, here chlorine is there, and CH2 bond CH2 plus, here it is attaches with the bromine, and CH2 bond CH2 plus it is attaches with the iodine. Now in this one, my question is write the increasing order of the stability of the carbocations. Right? The increasing order of the stability of the carbocations. So which one is the more stable? Aditi,
Yes, sir.
which one is the more stable one, ma? Four structures it is there. In four structures, they are acting the increasing order. Increasing order means lowest to highest one. So which one is the more stable? What is the increasing order of the stability? Tanishk,
So fluorine is the most stable.
ma? How it is the more stable, Aditi? Aditi, can you check it out the electron withdrawing strength? If you see the electron withdrawing strength is fluorine is the strong electron withdrawing group than that of the chlorine. So chlorine is more electron withdrawing group than that of the bromine. So bromine is strong electron withdrawing group than that of the iodine. Such stability is inversely proportional to strength of the electron withdrawing groups.
So the
Stability,
one, so
yeah.
the atom which doesn't withdraw the electron that much comparatively is the most stable one. So iodine is the most stable, then bromine, chlorine, then fluorine, right?
Exactly, Aditi. Exactly. So whatever the answer you had given, exactly correct answer now. Very good. Okay. Now, so which one is the more stable one means here? Sir, so iodine is the more stable. So because of greater the strength of the ligand means, so weaker the stability. They have a less stable. Okay. The stability is very less. So that times here, the element which is weak electron donating group or weak electron withdrawing group, so that it becomes as a more stable. So due to that reason only, so which one is the more stable one means here iodo-ethyl carbocation. So which one is the more stable one here? Iodo-ethyl carbocation is the more stable. Okay, so because of stability is inversely proportional to strength of the ligands here. Okay, so weaker the strength of the ligand, greater the stability. Stronger the strength of the ligand, lesser the stability. So in this one, which one is the stronger the electron withdrawing group means fluorine. That means fluorine it becomes as a lesser the stable. Okay, so weaker the electron strength of the ligand means that it becomes as a more stable. So that's why iodo-ethyl carbocation is becomes as a more stable. Still anyone you are having doubt? Is anyone having doubt? And I'm going to frame one more question to you, ma. Okay, I'm going to frame one more question. So all these are the different applications. So what is another example means here? I'll write CH3 bond CH2 plus CH2 bond F bond CH2 plus CH2 CH F2 bond CH2 plus and CF3 bond CH2 plus. So which one is more stable? My question is, which one is the more stable? Ethyl carbocation, fluoroethyl carbocation, difluoroethyl carbocation, trifluoroethyl carbocation. Tanishk, which one is more stable, Tanishk?
no idea, sir.
No idea, na? So you're not applying the concept, Tanishk. Tanishk, what is the electron withdrawing group is there in given compounds? Fluorine is it act as an electron withdrawing group or electron donating group, Tanishk?
Withdrawing, sir.
If it is withdrawing group means here number of electron withdrawing groups are increases, stability is going to be decreases na? Because of stability is inversely proportional to the number of electron withdrawing groups. Is that clear?
Yes, sir.
Okay. Now inversely proportional. If you see the first structure means we have a zero number of electron withdrawing groups. If you see the second structure means we have a one electron withdrawing group. If you see the third structure means we have a two electron withdrawing groups. And if you see the third one means we have a three electron withdrawing groups. Okay. So according to that one, according to the statement, number of electron withdrawing groups are increases. Stability is going to be decreases. According to that, my question is which one is the more stable and which one is the least stable about out of these four options, ma? Which one is more stable and which one is the least stable one? Samita,
Yes, sir.
which one is the more stable and which one is the least?
Least stable will be CF3H2, I think.
Okay, ma. Least stable one is CF3, CH2 plus. Then which one is the more stable?
CH3, CH2.
CH3, CH2 is the more stable. Some CH3, CH2 too. The stability order is going to be decreases. Why the stability order is going to be decreases means here stability is inversely proportional to the number of electron withdrawing groups. So now all of you got the clarity how to explain the stability of the carbocations. Is that clear, everyone? Is that clear?
Yes, sir.
So right now, so then we'll go for the second application. Sir, what is the second application means here? Sir, we can explain stability of the free radicals also. Okay, so which one we can explain means here? We can explain stability of the free radicals. Okay, so second application is we can explain stability of free radicals. Stability of free radicals. So what is meant by the free radicals? Any one of you, which we can call as a free radical? Which we can call as a free radical, ma? What is meant by the free radical? No one is giving the answer. Forgot, otherwise what I have to understand. What is meant by the free radical? Sir, free radicals are obtained by the homolytic cleavage. So which we can call as a free radicals means here the atoms or molecules which contains odd number of electrons. The atoms or molecules which contains the odd number of electrons is called as a free radicals. Okay, so free radicals are paramagnetic or diamagnetic? Aditi, is free radicals are paramagnetic or diamagnetic? I think so. Whether you are having time or not, I don't know exactly. So please
So
just
paramagnetic.
paramagnetic. So free radicals are paramagnetic in nature. Okay. So please just go through your previous notes while coming to the class. Because of if you forgot the previous class means, so and next class is very difficult to listen and you won't understand what I'm teaching also. I'm teaching only basics, ma. If you understand this one, if you are thorough with the basics means, then I'll increase my speed and I can start the 12th standard chapters here. Okay, all these concepts are interrelated to 12th standard concepts. You got the clarity, all of you? In 12th standard, what are the haloalkanes, haloarenes chapter, alcohols, phenols, ethers, everything, all these chapters are interlinked to this chapter. Okay, so that's why once you listen clearly, okay, and just you remember, we can practice more. If you practice more, means definitely you'll get. Right, sir? So here, stability of the free radicals. Free radicals are paramagnetics. First of all, I'll explain the free radical. So free radicals are nothing but atoms or molecules which contains the odd number of electrons is called as a free radicals. Free radicals are obtained by the homolytic cleavage. Free radicals can be represented with the dot symbols. Okay, so we wrote one stability also. Stability of the free radicals is directly proportional to plus I groups and inversely proportional to minus I groups. Okay, now already we had seen the stability of the carbocations. Stability of the carbocations and stability of the free radicals are similar only. Okay, but only the thing is what's the difference it is there in the stability of the carbocations and stability of the free radicals means carbocations means the carbon which contains the positive charge is called as a carbocations. Okay, free radicals means we are representing with the dot symbol. Now again, I'm giving some of the questions here. Let's see who's going to give the answer. First example. First example, sir. So all of you, do you have any idea about the lining structures? Sir. Here I have given three structures, sir. So, sorry. Structures is correct only. Representation only is the different. Right, sir. This one is we can write like this here, and here right now. Here we can write as a one dot symbol. Okay, and here also we can write as a dot, and here also we can write as a dot, one dot here, and here also one dot it is there, and here we are placing as a one dot. Okay, now in this one my question is, so which one is the more stable? Which one is more stable? I had given three structures. Three I had given as a line structures. Which one is the more stable? So generally we can call as a lining representation. This we can call as a line representation. Which one is the more stable one? No one is giving the answers.
So can you repeat the question again?
So I had given three structures. So which one is the more stable one, ma? That is my question. Which one is the more stable one? So to find out the stability means, first of all, you have to find out which one is the primary free radical, secondary free radical, and tertiary free radical. Okay. Now, so which one is the primary free radical, ma? Free radicals can be represented with the dot symbols. So wherever the dot it is there, that carbon. Okay, so dotted carbon is called as a free radical carbon.
So
Okay,
first one is primary,
very good, Aditi. Next,
it's secondary, and the third one is tertiary,
very
and
good, Aditi.
it's in increasing order.
So increasing order. So that means primary to tertiary stability also is going to be increases. Sir, how you are telling the stability also is going to be increases means because the stability of the free radicals is directly proportional to plus I groups. Number of electron donating groups are increases. Stability also is going to be increases. Sir, which one we can consider as a plus I groups means here? Plus I groups are nothing but alkyl groups. Now, if you see in this one, this carbon is attaches with the ethyl group. One side it is attaches with the propyl group. One side is attaches with the methyl group. And if you compare this carbon means this carbon is attaches with the three methyl groups. Number of alkyl groups are increases. Their stability also is going to be increases. Okay. And Samhita. Samhita in second example. Which one is the most stable? I had given three structures.
Yes, sir.
Which one is the most stable one, ma? Sirisha, Tanishk. Stability order from first to third. Three different structures are there. Which one is the more stable one? Samhita?
Sir, I think this is the third one.
Third one is the more
Third
stable.
one, sir.
So why the third one is the more stable, Samhita? Correct only, ma. Whatever the answer is, that is correct only. Why the third one is the more
Because
stable?
the electron density is inside the aryl group
No.
in the
So
cycle.
here, so this carbon is the tertiary carbon, ma. Simple reason. So what are the third one is the tertiary carbon, tertiary free radical. And in this one, we can call as this carbon is the secondary free radical. So this is the primary free radical. Okay. So according to that reason here, tertiary free radical is more stable than that of the secondary and primary. And one more example, sir. One more example I can give you here. For example, if in line structure only, I'll write here. So uh, dot symbol I'm writing. This one is attached with the NO2 and another one I'm writing as a dot symbol. This one is attached with the CN and another symbol is it is also dot symbol. So this one is attached with the fluorine. So according to these three structures, so which one is the more stable one? Might we solve these are the JEE type of questions. If you understand means it is good for you only. Which one is the more stable one? Stability order. Which one is more stable? No one is giving the answers. I'm writing the examples only. Write the stability order. That is my question. You can apply the concepts which we studied before.
So what's the answer for the third one? Can you explain it?
No. Third one, what is the stability order? Which one is the most stable? So which one is the most stable means here first we have to check it out. All are the secondary free radicals only. If you observe the structures means all are the secondary free radicals only. But in that one, we have to check it out the electron withdrawing groups. All secondary radicals are the attaches with the electron withdrawing group. So what are the electron
So the
withdrawing
second
groups
one
are?
is more stable. The second structure is more stable than the first one, and the third one.
Aditi, somewhat link is missing because of if you still see the strength of the electron withdrawing groups, nitro group is the strong electron withdrawing group. After that, cyanide. After the cyanide, cyanide is the strong electron withdrawing group while comparing with the fluorine. So this is the strength. So strength, electron, all these are the minus I groups only. Minus I groups and stability is inversely proportional or directly proportional? Aditi.
It's inversely proportional.
It is inversely proportional means here, so whichever the weaker the strength here, weaker the ligands, greater the stability. Okay, so greater the electron withdrawing group, lesser the stability. So as per that one, which one is the more stable?
So the third one is more stable than the second one, than the first one.
Very good, Aditi. Now you got the clarity. Okay.
So, and the next one, the third one is more stable than second one, then the first one is the least stable.
Very good one. Next, last one. Last one.
So the third one is more stable because it has a methyl group.
Which one is the more stable?
The third one.
Third one. This one.
Yeah.
Yeah, here one fluorine atom is there. Right. Now, third one is the more stable.
Methyl group. Then the second one is more stable than the first one because it has
Very,
3 atoms.
very good, ma. Here, number of electron withdrawing groups, we can check it out. So, last one we can explain based on the number of electron withdrawing groups. Number of electron withdrawing groups are increases. The stability also is going to be decreases. So, in this one, first one is having the 3 electron withdrawing groups. Second one is having the 2 electron withdrawing groups. Third one is having only 1 electron withdrawing group. So that's why, so third one is more stable than second one. Second one is more stable than the third one. So all these are the different examples which we can explain based on the stability of the free radicals. So now you got the clarity, all of you? All of you got the clarity? Okay, then we'll go for the next concept. So what is the another concept means here? So next we can explain stability of carbene ions. So what is meant by the carbene ion, which we can call as a carbene ion? Srisha, what is mean by the carbene ion? Stability of carbene ion. So which we can call as a carbene ion. Samhita, what is mean the carbene ion? Tanishq? Tanishq, I think so you attended for that class. Reaction intermediates, reagents class you attended. What is mean by the carbene ion? Samhita is giving answer.
Has a negative charge.
The carbon which is having the negative charge is called as a carbene. Yes, ma'am. Negatively charged carbon atoms are called as a carbene ion. Okay. Sir, what is the stability order of the carbene ions means here? Stability is directly proportional to minus I groups and inversely proportional to plus I groups. Okay, it is exactly opposite to stability of the carbocations and stability of the free radicals. So stability of the carbene ions is exactly opposite one. Stability of the carbene ion is directly proportional to minus I groups and inversely proportional to the plus I groups. So according to that only, what we wrote the stability of the carbene ions? Stability of the carbene ions is we wrote as a primary carbene ion is more stable. That means methyl carbene ion is more stable than primary carbene ion. CH3 bond, CH2 minus. Okay. And so secondary carbene ion, primary carbene ion is more stable than the secondary carbene ion. CH minus bond CH3 is greater than CH3 bond, C bond CH3 bond CH3 minus. Sir, why the methyl carbene ion is more stable than primary and secondary and tertiary? So this is our question. Okay, so this is only our question here. If you observe means here, first the carbene ion. So this is the carbene ion. So which we can call as a carbene ion. The carbon which is attaches with the negative charge is called as a carbene ion. So carbene ions are attaches with which one? Methyl groups. Here also one methyl group it is there. Here also two methyl groups are there. Here also the carbon is surrounded by the three methyl groups. Is methyl group is attacked as a plus I group or minus I groups? Is methyl group is attacked as a plus I group or minus I groups? So first of all, while coming tomorrow, first you read plus I groups and minus I groups. You have to by hand that one. Okay. All of you got the clarity? Sir, here all these are the methyl group is the electron donating group. So what is the statement? Stability is inversely proportional to the number of plus I groups. If you see means this one is attaches with the three methyl groups. In this one carbene ion is attaches with the two methyl groups. In this one attaches with the one methyl group. Here 0. Number of electron donating groups are increases. Stability is going to be decreases. Now you got the clarity all of you? Number of electron donating groups are increases, stability is going to be decreases. So due to that reason only, tertiary carbene ion is least stable than that of the methyl carbene ion. Okay, so all of you got the clarity? Samita, Aditi?
Yes, sir.
Okay, now and one more example, ma. So based on that one, you have some questions in your assignments and all, you can check it out. I'm giving one more example. CH2 bond, CH2 minus. Here this one is attaches with the NO2 and CH2 bond, CH2 minus. Here we have a F. So if you compare these two, so which one is the more stable one? Any one of you? Which one is the more stable carbene ion? First, you can check it out the statement. What is the statement? It is the stability is directly proportional to the minus side. If it is minus I means nitro group also it is the minus I group only. F also it is the minus I group only. But in this one, how we can explain the stability? Stronger the electron withdrawing group means greater the stability. Okay. Now in nitro group and fluorine, which one is stronger the electron withdrawing group, Aditi? In nitro and fluorine, which one is the stronger the electron withdrawing group? NO2 is the stronger the electron withdrawing group. So that's why, so NO2 is more stable than that of the fluorine. So now you got the clarity. So first of all, now I'm going to forward the notes. Please read once, go through the notes and you by heart the electron withdrawing groups and electron donating groups. Then only whatever I'm teaching you are able to understand. Otherwise, it is not possible to understand. You got the clarity? So we'll continue in the next class. Thank you all.